Hello everyone. Today we are going to start a new chapter which is language of chemistry. Myself, Suman Singh. So in this chapter what we have to learn we will see first. So in this chapter we have to learn about the symbols of the element and their valencies. Okay. Now next is symbols of radicals and their valencies. Okay. Now next is formation of compound on the basis of symbols and valencies of element and radical. Okay. Now next is to write the chemical equation from the word equation by knowing the formula of the reactant and product. Okay. After that we will see law of conservation of mass. Next we will see balancing of chemical equation, how to balance the chemical equation, we will see that. Okay. And after that we will see the information obtained from chemical equation, what are the information we can obtain from the chemical equations. And after that at last we will see the limitation of chemical equations. Okay. So first of all, we will start with the symbols. So what is symbols or what is chemical symbols of the element? We have discussed about this chemical symbols or chemical about the chemical symbols in our previous chapters, right? So I hope you all have some idea about the symbols, right? So what is the symbol? Symbol is just a shorthand representation of the atom, okay, of a specific element. As you can see, it is also written here. What is a symbol? A symbol is a shorthand representation for the atom of a specific element, okay, and each chemical element has its own unique symbols. Means what? No two elements will have a same symbol, okay. I hope you have understood this, just like the hydrogen for H, oxygen for O, carbon for C, okay, chlorine for Cl, and nitrogen for N. So you will see this, right? So you will see that each element will have their own unique symbols, okay. So but why is it necessary to represent the elements with their symbols, or we can say how were the symbols derived? So these are the two basic questions which we have to think, why there was a need to represent the element with their symbols and how were the symbols derived. Okay. So for the answer for the first question is that because the symbols, when we are using the symbols, it will save our time, space and energy. Okay. As you can see, for writing hydrogen, Hydrogen, right, it took so much time and space, right, as you can see. But if we are representing with this hydrogen, it has saved our time as well as space as well as energy, right? So because I will like to tell you one story. Because or we can also think like this, that if science suppose the scientist, if when we talk about the scientist, if any scientist is there and who is doing an experiment with this hydrogen and chlorine, okay, suppose hydrogen and chlorine. So if whatever the experiment he will do, but he has to write, right, he has to write that experiment in his note copy or somewhere, anywhere somewhere else, right? So at the time of writing, each and every time when he have to write hydrogen, he has to write all, right, HYDROG and CHLORINE chlorine, right? So it will become difficult because it will take more time also, and as well as it will take more space also, right? So that is why there was a need was felt to develop the elements with their symbols, or we have to represent the elements with their symbols. Okay. So I hope you have got the ideas now how these symbols was derived. So as we know that the use of symbol of the for the element existed long before, okay, and a systematic method was developed. It was a the use of symbol of this element, of the elements, existed long before, and there was a systematic method, and or we can say there was a systematic method was developed to represent the symbols of the element, right? When we talk about the alchemist associate the symbol of the planets not only with the days or week, but also with the seven metals known as gold, silver, iron, mercury, tin, copper and lead. So when we talk about the alchemist, the alchemist used to associate the symbols of the planet not only with the days or week, but also with the seven metals which were known at that time, that was gold, silver, iron, mercury, tin, copper and lead, right? Now next is, by the beginning of the 19th century, by the beginning of the 19th century, only 26 elements were known. Okay, and which increased up to 81 in the 20th century. Means what? At the with the big in the beginning of the 19th century there was only 26 elements were known, but by the that was increased day by day, and it reached 81 at the end of the 20th century, or we can say that with the increase up to 81 in the 20th century, because in 20th century there was 81 elements were known at that time, right? Now, as we know that as more and more elements were discovered, right, the need for the symbolic representation for the element become more and more evident, right? Because more and more elements were discovered, and it become very difficult to write, or it become very difficult to write, or we can say that to represent each and every time to represent each and every time that element with its full name, right? So there was a need to symbolize the element. Okay, so what happened? The first step was took by a Swedish scientist in 19th century named John Jacob Brazilius. Okay, what he did, he systematically assigned the first letter in capital as a symbol of the element. What he did, he told that he was the first scientist who systematically assigned the first letter. He told that whatever the first letter of the element name will be the symbol of that element. Okay, if the first name is or if the name is oxygen, so it's oxygen starts with what? O, right? So O will be the symbol of this element. Okay, such as you can see, oxygen for O for oxygen, this is the first letter, it is represented in capital letter. Okay, O for oxygen, H for hydrogen, C for carbon, N for nitrogen, and so on, right? So in this way, this Bacillus has given, or we can say that assigned the first letter of the name in capital as a symbol of the element, right? Later on, it was found the basis for of IUPAC system of chemical symbols and formula. So IUPAC is what? It is a union of pure and applied chemistry, or we can say that it is a branch, or we can say it is an institute who decide everything about the chemistry. Okay, what will be the name, what will be the physical property, chemical property, any reactivity, reactions, oxidation, everything. He used to decide, right? So later on it was found that whatever the idea which was given by Brazilius, it was adopted by this IUPAC to name it, to name the symbols and the formula, right? Now next is, we will see one by one with the example. So first is what? Each symbols is denoted by each element is denoted by a symbol, right? And what was that? That was usually the first letter of the name in English or in Latin. Okay, for example, you can see OXYZEN. Oxygen was given a name O. Hydrogen was given a name H. Carbon was denoted by C. Okay, and in the same way, nitrogen is denoted by N, and so on, right? So as you can see, one example is given here. Oxygen is the element, it is denoted by a symbol O. Similarly, the hydrogen is denoted by symbol H. And now it is nowadays, if we talk about today's world, the IUPAC approve the name and the symbol of the element. Okay, he used to approve the name and the symbol of the element, right? Now next is, if in any element the first letter is same, suppose you see the example. Okay, first of all, we will see what is written here. When the first letter of the more than one element is same, right, the symbol is denoted by two letters. The first letter is written in capital, while the second letter is written in a small letter. Example, you can see, you see the example, a very good example is here. And what it has been asked, told here, that if the name of the element if the first letter of the name of the elements are same, then at that time what we will do, we will use the capital letter of that element as the first letter, and the just next to that we will use is that as a small letter. Let me tell you here. You have carbon, cobalt, calcium and chromium and chlorine, right? You see, this is also, this carbon also starts with C, cobalt also start with C, calcium also start with C, chromium also start with C, and chlorine also starts with C, right? So it will be, if you will give C for this also, for this also, for this also, it will be difficult, right, to identify this is carbon or this is a cobalt or this is a calcium. So what it has been told that if two, if the name of the elements of the first letter is similar, at that time we will use what, first two letter, first two letter we will use, right? First two letter we will use, first two letter we will use. Okay, if first two letter are also same, at that time we will use first and third letter. Okay, so first two letter we will see. For carbon, for cobalt, carbon has been given C. Okay, no need to talk about that. But for cobalt, COBALT. Okay, and for calcium, CALCIUM. So as you can see, C are same, right? So what we have, what we have done, we have used cobalt as a CO. Okay, first one is capital and second one is small, as you can see, right? And for calcium again, first one is capital and second one is small, as you can see, CA, right? CA, the first two letter we have used, in which first letter will be capital and the small letter, second letter will be small letter. Here also first letter is capital and the second letter is small letter, right? Now next, if the first two letters are same, suppose in the example of chromium, CHROMIUM. Okay, chromium, and chlorine, CHLORINE. So at that time you can see here, this is also CH, this is also CH. So what we will do at that time, what we have to do, we have to choose the first and third letter. Okay, so for chromium we have to use C and R, and for chlorine we have used C and L. For chromium we have used Cr, and for chlorine we have used Cl, right? I hope you have understood this, right? So we will see here. Cobalt, carbon, cobalt, calcium and chromium and chlorine are the element whose first letter C, right, is C. Carbon is denoted by C. Okay, cobalt is denoted by CO, calcium is denoted by CO is Ca, chromium is denoted by Cr, and chlorine is denoted by Cl. Okay, so I hope you have understood this, right? Now next is the symbol of, so symbol also represent an atom of that element. Means what, whatever the symbols we are using, that also represent the atoms of that element. For example, hydrogen, for when we talk about the hydrogen, H, you here H represent the element hydrogen as well as the atom of hydrogen. Okay, when we talk about the carbon, here carbon C represent the element carbon as well as one atom of carbon. Okay, in the same way, if you are taking here O represent the symbol. If you are taking here O represent the element. Okay, element oxygen as well as one atom of oxygen. Okay, so I hope you have understood this, right? Now next is number 4. Some symbols have been taken from the name of the element in Latin, Greek, Latin, German and Greek, because some of the elements you will see that is not taken with the English letter. Okay, they have been taken either from the Latin, German or Greek. Why? Because the name was becoming same, that is why, right? So what was that element? We will see the first, the very famous element is iron. Okay, iron, which is denoted by Fe. Iron should be denoted by Ir, right? Ir, or it should be denoted by IO or In, right? But it is not like that. It has been represented with the its Latin name ferrum, FERRUM, ferrum. Ferrum, for the first two letter we are using Fe, right? For iron we are using Fe, and mm, it has been given the name from its Latin word ferrum, right? As you can see, the symbol of iron is Fe from its Latin name ferrum, right? In the same way, sodium has been given the name, has a symbol of Na from its Latin name, which is natrium, Natrium. Okay, in the same way, potassium has been given its name K from kalium, Kalium, kalium. Okay, in the same way, copper has been given a name Cu from cuprum, cuprum, cuprum. Okay, so therefore each element has a name and its unique chemical symbol. Okay, so I hope you have understood this, right? For iron, sorry, for iron we have taken from here, right? So for iron, we have taken from the Latin name ferrum, Fe. For sodium, natrium from Na, kalium, Ka for potassium, cuprum for Cu, copper, right? So I hope you have understood this, right? So as you can see, one table is given here, and here in this table, the elements and their symbols are given. Okay, as you can see, when we talk about the sodium, okay, sodium, when we talk about the sodium, sodium has been taken from the Latin or Greek word which is called natrium, and its symbol is Na. Potassium taken from kalium, its symbol is K. Magnesium is taken from manganesia, example its symbol is Mg. In this way you can see some of the examples are given here. Okay, and here the symbols is hydrogen for H, okay, helium for He, nitrogen for N, neon for Ne. So these are some of the example as you can see here, right? Now next is what? Valency. So valency we have learned just in the previous chapter, right? So I hope you have all got the idea about the valency, what is valency and all, right? So what is valency? So valency is what we have seen. It is the combining capacity of an atom, okay, of an element or a radical with atom of other element or a radical to form molecule, right? Valency is what? It is a combining capacity of an atom of an element or a radical with the atom of other element or radical to form what? Molecules, right? Now next is what? The valency of an element or a radical is the what? The number of hydrogen atom that will combine with or displace one atom of that element or a radical. We have discussed about this, right, in the previous chapters. So now some of the example is given. 4 examples are given, you will see that, right? So first example is the valency of hydrogen is taken as 1. So the case is the example of hydrogen chloride. When you will see the case of hydrogen chloride, here you will see that hydrogen, one atom of chlorine, here one atom of chlorine combined with one atom of hydrogen, right? So what will be the valency of chlorine here? Valency of chlorine will be 1 and the valency of hydrogen will be 1, right? Now again when we talk about the H2O, at that time you can see one atom of oxygen combined with the two atom of hydrogen, right? So at that time the valency of oxygen will be 2, right? Valency of oxygen will be 2, right? Now next is ammonia. So as you can see, one atom of nitrogen combined with 3 atom of hydrogen, right? NH3 means one atom of nitrogen combined with 3 atom of hydrogen, right? So at that time what will be the valency of nitrogen? It will be 3, right? We have discussed this. Now next is CH4. Again in methane, CH4 molecule, one carbon atom combined with 4 atom of hydrogen, okay, hence the valency is 4. As you can see, CH4 in CH4 is like this. CH4 1 2 3 and 4 here. So as you can see, one atom of carbon combined with 1 2 3 and 4 atom of hydrogen, so the valency of carbon will be 4, right? So I hope you have understood this, and you will notice that the valency of an element increases from 1 to 4 and then it decreases to 1. We have discussed about this, right? For some element like helium, neon, argon, the combining capacity is 0. We have also discussed about this, right? In valency we will say that when we will see the valency, it will increase from 1 to 4, and again it will decrease from 4 to 1 and then to 0, right? For 0 is what? For noble gases, whatever the inert gases are there, they have a 0 valencies, right? Because they do not combine with any other elements, just like in the case of helium, neon, argon, krypton, xenon and radon, right? They all have a combining capacity is 0 because they are inert gases and their outermost shell is complete, right? So I hope you have understood up to this, right? And there is one table is given. This table you should write in your copy, okay? You write this table in your copy because it is important. Here you can see there is a name is given, name of the element is given here, okay? Name of the element is given and the symbols are given, right? Symbols is given and valency is given. So up to how much it is given? 20, right? So this 20 you should write in your copy, okay? And you should memorize this. This will help you in solving the in writing the formula. When you will write the formula at that time, it will help you in writing the formula. So this should be written in your copy, okay? So for today only we will discuss up to this only, okay? So I hope today's class you have understood. So in the next class we will talk about the variable valencies and free radicals and all, right? Till now, till that, thank you.